count query and our skip and take operation. So let me accept this auto-completion and see if this is what we are looking for. And you will see that this closely matches to what I was already doing inside of the endpoint. I have a total count query, and then I'm applying the skip and take operators to perform offset pagination. Finally, I can create a pagination result to get back my items. Now, how do we use this? Back in our habits controller, I can omit the total count query that I was performing here, and we also don't need to manually do the skip and take operators here. So let's remove those. So what am I left with? I'm applying my sorting here and my projection. And both of these are something that I should include in the original query. So let's move them into our query, but this now becomes an iQueryable of the iHabit DTO. Then I can get rid of the habits variable because we no longer need it, and we're not going to create the pagination result manually. Instead, we can use the create async method. It can accept a habits query, which we already have, and the page and page size parameters that we have inside of our query parameters. We have to await this because it's an async method, and this will return a pagination result that we can return from this endpoint. Then we have to fix the return type of our endpoint, which returns a pagination result of a habit DTO, and now I should be able to start the application and test out this implementation. Let's construct a query that's going to return the first page, which is also the default page, and I want to set the page size to free records. And if I send this request, we'll get back a 200 OK response, where the response contains our top level items with free records inside, and then we have our pagination metadata. So you can see that the current page is 1, the page size is free, this is just copied from our request. The total count is 15, and based on the current parameters, the total number of pages is 5. We don't have a previous page, and we do have a next page. Now let me update the page size to 2, and you can see how the metadata changes. We get the next page of habits, and in the metadata, we're now on the second page. We have a previous page, and we also have a next page. If I go to page 5, we're going to get back the habits on this page, and this time you can see that we no longer have a next page because we are up to the last page, and we also don't have a previous page. Now if you specify a page which is out of bounds, you will just get back a response without any items inside. So our pagination is working as expected so far. Now let me send this request again, and I placed a breakpoint in the backend so that we can walk through the individual steps. So we are applying our searching and filtering, and we are also applying our sorting and our projection, and moving all of that into an iQueryable. This contains our query definition that we can use inside of the pagination result, where I have a helper method that's going to perform the count, and it's going to extract the current page of items from the database and materialize everything into a pagination result. So now I can return this pagination result inside of my endpoint, and I have a reusable way to implement paging in my other endpoints. If we take a look at our distributed trace, you can see that for fetching the habits, we have two database queries. The first one is our count statement, which performs select count and also applies our filters. Now we don't have any, which is why we just have count star. Now inside of our second query is where we are applying paging, and you can see this by the limit and the offset operator that are present in the SQL query. Now let's make our query more interesting by selecting the first page. I want to select 10 records. I also want to sort them based on the name in ascending order, and then based on the frequency type, and I will properly specify this in descending order. And then let's also apply a filter based on the type and the status of our habit. And let's send this request, and I should have gotten back a response if I didn't mix up my query parameters. So let me fix the page and the page size, and then send this query again, and you can see that we are getting back some habits that satisfy this condition, and we have just 2 of them in total. But if I take a look at the distributed trace and the 2 queries that are sent this time, you can see that it's slightly different. This time we are properly applying the where statement inside of the count query, so this is being translated correctly into SQL, and even though we are applying sorting, it is being omitted because sorting isn't relevant for a count query. In our second query, which is actually selecting the columns that we are returning inside of a given page of records, we do have both the where statement on the habit type and the habit status, and we're also applying sorting based on the name and the frequency type in descending order before performing pagination. Another thing that's important here, if I omit this sort order and send this request, you will see that we get back the same two responses. And what I want to focus on is our second select statement, which is going to return the current page of habits, and notice that we have our default sort order always specified. This is super important when you are doing pagination. You always want to sort your records based on some unique value. In this case, I'm performing a default sort order based on the primary key of this table, which is the habit identifier. You can also do a default sorting on some timestamp column, like the created at UTC, but nonetheless, if you aren't performing sorting, then you won't get back the correct set of results. So this is something that I want you to always keep in mind. Let's also briefly discuss the metadata that we are returning here inside of the pagination result. This information can be useful for your client to enable or disable the available actions on the user interface, but this is just a means to an end. Where this becomes really powerful is when you introduce HateOS together with pagination and you start properly constructing the links to the next or the previous page of results, where your client can just use the links that you already constructed on the backend. I'm going to demonstrate this in our next chapter when we start talking about HateOS. And with this, we have completed our implementation of offset-based pagination inside of our REST API. Pagination is going to help us improve performance by reducing the number of records that we are retrieving from the database and also reducing the amount of data that we are transferring over the network. A reminder that I'm going to cover cursor-based pagination in a separate lesson in the Advanced Concerns chapter. So don't worry, you will see how to implement both types of pagination inside of your REST API. Now we can slowly move into our next lesson, where we will be talking about data shaping inside of our REST API.